In projectile motion, an object is solely supported by gravity and moves in both vertical y-axis and horizontal as x-axis directions. Projectiles have many examples. An object that is propelled upward at angle to the horizontal or that is dropped from rest or thrown vertically upward is referred to as a projectile. A projectile can also be shown by any propelled object that keeps moving because of gravity's pulls and its inertia. Understanding basic pneumatic ideas like uniform motion, accelerated motion, equations of motion and others is aided by the analysis of projectile motions. In addition, the ping-pong ball's launcher's main objective was to hit a particular target from a distance both horizontal and vertically. The project comes with a platform for launching that has different energy settings. In addition, the platform's angle needs to be adjustable to retain structural integrity, longevity, and dynamics at various launching angles. The projectile launcher equipment must be manufactured by hand. Adjustments are required to increase the target distance, compatibility, comfort, and visual appeal. Machine and dynamic mechanics are essential for this project. We'll ultimately acquire skills in design, analysis, fabrication, and testing.
The objectives of projectile motion of ping pong are: number one, to construct a launcher specifically for projectiles made of ping pong balls. Second, to determine the energy form that is employed in the system in question. To recognize, establish, and appreciate the energy conservation principle. To identify and calculate the system's projectile motion. And the last one, to learn about and use the law of conservation of energy and projectile motion in practical situations.
Mechanism. A ball-stick device known as a catapult is used to launch projectiles over great distance without the need for propellant, switches, gunpowder, or other materials. Construction systems that employ gravity, torque, and tension are the source of the stored energy. The catapult then suddenly releases its stored potential energy to propel its cargo. The majority is use springs, bows, twister rope, elastic, or any of some other materials and technique to transfer the tension or torsion energy that was gradually and laboriously built up within the device before release. The ping pong ball accelerates due to the force applied by the launcher springs. This relates the Newton's second law, which says that an object force is equal to its mass times its acceleration. He launcher convert the kinetic energy of the ping pong ball into the potential energy contained in the compressed spring. The way the ping pong ball moves is governed by a field of mechanics called kinematics. Motion, displacement, velocity, and acceleration are topics that machine mechanics commonly explore. Material used is: first, we use ping pong ball; second, wooden stick, hot glue gun, clamping pin, binding tape, skewer sticks, and measuring tapes.
from the ping pong launcher that we made, we find the angle using the theorem Pythagoras theory. Okay. After calculating the length, height, and weight, we get the angle of our launcher, which is 57.77 degree. To find the velocity of our launcher, we use the kinematic equation, which is for x-axis is x equal to xo plus v times by t. And for the y-axis, we use y equal to y origin plus v times t plus 1/2 acceleration times t squared. And then based on our data, we fill in the equation from x-axis and y-axis to get equation 1 and equation 2. The equation 1 that we get is v equal to 0.6 divided by cos 57.77 times t. And for the equation 2, we get 0.8 equal to 0.15 plus v sine 57.77 degree times t plus 1/2 times negative 9.81 times by t squared. After that, we substitute equation 1 into equation 2. From that, we can get t, which is time of flight, and we get 0.247 seconds. After we get the time, and then we substitute time into our first equation, and that we can get the final answer, which is velocity equal to 4.55 meter per second squared. By using the formula K equal to F divided by X, according to the Hooke's law, rubber band that we use for our project is constant based on the data we recorded from the testing and the graph above.
Okay, for the discussion, due to the lightweight material, the ping pong balls significantly affected by air resistance and spin. So the physics of projection is also relevant here, which is the launcher will likely propel the ball in a parabolic trajectory with gravity as the only force acting upon it. You need to consider both the horizontal and vertical components of its velocity in terms of ping pong ball's motion. The horizontal will remain constant due to the law of inertia, while the vertical will be affected by gravity, which causing the ball to accelerate downwards. And it also important to take into account the unique properties of ping pong balls and the physics of projectile motion to ensure that the launcher meets your desired specification when designing the launcher for the ping pong ball. While designing the launcher, this also may involve adjusting the launch angle, launch speed, and other factors to achieve the desired trajectory and range for the ball. That's all for the discussion for this Simon Ping Pong by Group 5. Thank you.
In conclusion, a ping pong ball's launcher is a practical and effective tool of exploring the principle of project motion. The light The lightweight and aerodynamic properties of ping-pong balls make them ideal and demonstrated in the effect of air resistance and spin on a project trajectory. The design of a ping-pong ball's launcher must take into account the design launch angle, velocity, and the mechanical precision. The launcher ability to accurately propel balls into a target such as a basket with a set time frame is a testament to the understanding and application to project motion physics.